the harbor feels off. You notice it right away. The fishing boats sit tilted on dry ground, their hulls dark with old salt stains. The pier stretches out over nothing but cracked mud and scattered shells. Even the seagulls seem confused, still showing up each morning out of habit, circling over land where water used to be. This isn't some ancient geological shift. People remember when this was different. The older fishermen can point to rocks that used to be underwater, describe exactly how the tide used to sound when it came in at night. Their children grew up swimming here. Now those same children bring their own kids to see the boats that can't float anymore. This transformation happened so gradually that many didn't notice until it was undeniable. Harbor bells that once marked the rhythm of tides now hang silent above dry land. The boats that remain have settled so deeply into the sediment that local children use them as playground equipment, never knowing these vessels once carried their grandparents across deep water. This is not a scene from some distant apocalyptic future. This is happening right now, in dozens of places across our planet, as the ocean retreats faster than anyone predicted. While we've grown accustomed to hearing about rising sea levels threatening coastal cities, a quieter catastrophe unfolds in the opposite direction. Bodies of water that have existed for millennia are shrinking, disappearing, or shifting away from the lands they once nourished. The Aral Sea, once the fourth largest lake in the world, now covers less than 10% of its original area. In the 1960s, Soviet planners diverted the rivers that fed this inland sea to irrigate cotton fields in the surrounding desert. They believed they could engineer a better relationship between human needs and natural resources. What they created instead was one of the most dramatic environmental collapses in recorded history. Ships that once carried cargo across waters deep enough to hide their anchors now sit stranded in what locals call the ship graveyard. Their rusted hulls rise from sand dunes like monuments to a lost world. The fishing villages that dotted the original shoreline now find themselves in the middle of a desert, hundreds of kilometers from the nearest water. Former fishermen have become camel herders or have abandoned their ancestral homes entirely. But the Aral Sea was just the beginning. Lake Chad, once one of Africa's largest bodies of fresh water, has shrunk by more than 90% since the 1960s. Where vast waters once supported fishing communities and provided drinking water for millions, there are now seasonal pools that disappear entirely during dry years. In the quiet morning hours before dawn, when the Mediterranean whispers against ancient shores, something profound is taking place beneath the surface. The sea that gave birth to civilization is slowly pulling away from the lands that have depended on it for thousands of years. Satellite measurements reveal that water levels have been dropping steadily, and the rate of decline is accelerating in ways that climate models failed to predict. Recent data shows that the Mediterranean has lost more water in the past 2 decades than in any similar period since measurements began. The people who live along these changing shores have developed an intimate understanding of loss that goes beyond scientific measurements. Elderly fishermen describe how they must walk farther each year to reach the water's edge. Their weathered hands trace maps in the sand, showing where the shoreline used to run when they were children. Marina operators in places like southern Spain and coastal Turkey report that harbors built just decades ago now require constant dredging to remain navigable. The sound of water lapping against dock posts, once constant as breathing, has been replaced by the scrape of boats dragging against sand. As we follow the threads of this disappearing water, we discover that the ocean's retreat is driven by forces both visible and hidden. The sun, which has always drawn moisture from the sea through evaporation, now works with unprecedented intensity. Heat waves that would have been considered extreme just decades ago have become regular occurrences, creating vast atmospheric engines that pull water vapor from the ocean's surface at accelerating rates. Modern meteorological stations record temperatures that break records established just years earlier. The heat doesn't just warm the surface, it penetrates deep into the water column, disrupting circulation patterns that have remained stable for thousands of years. But unlike the gentle cycle our ancestors knew, where evaporated water returned as rain to replenish what was lost, much of this moisture now travels far inland. The Amazon rainforest receives water that once belonged to the Atlantic. The mountains of Central Asia collect moisture drawn from the Mediterranean. Weather patterns have become a one-way conveyor belt, moving water from the oceans to places where it may remain trapped for decades or centuries. Meanwhile, deep beneath our feet, another story unfolds in the hidden world of groundwater. The vast underground rivers and reservoirs that have fed surface waters for millennia are being drained faster than nature can refill them. These aquifers, some of which contain water that fell as rain during the last ice age, represent humanity's deepest savings account. But we are spending this ancient inheritance at a rate that would shock our ancestors. In regions where agriculture has expanded to meet the needs of growing populations, wells reach deeper and deeper into the earth. Farmers describe how their wells must be drilled deeper each year, how the water table drops steadily away from their pumps like a retreating tide that never returns. This groundwater, once it's gone, may take thousands of years to naturally restore, if it ever does at all. As these underground reservoirs empty, the land above them often subsides, creating permanent depressions that can never again hold surface water. The engineers and planners of the past century built networks of dams and reservoirs that seemed like monuments to human ingenuity. The Hoover Dam, the Aswan Dam, China's Three Gorges project. These structures promise to control flooding, generate clean electricity, and store water for times of need. Yet they also fragmented the ancient pathways that carried snow melt from mountain peaks to the sea, trapping sediments and altering the delicate balance of salt and fresh water that countless species depend on for survival. Rivers that once flowed freely now pass through a series of artificial lakes, losing water to evaporation at each step. The Colorado River, which once carved the Grand Canyon, now rarely reaches the ocean at all. Behind each dam, massive reservoirs expose enormous surface areas to the sun and wind, accelerating evaporation rates far beyond what would occur in a natural river system. Lake Mead loses more water to evaporation each year than many entire states consume. As the years have passed, the jet streams that guide storms and seasonal rains across continents have begun to behave in ways that meteorologists struggle to predict. These high-altitude rivers of air depend on the ocean's vast thermal mass to maintain their strength and direction. Where once the ocean's enormous heat capacity helped stabilize global weather, creating predictable seasonal cycles, we now see erratic patterns that can trap moisture in some regions while leaving others in perpetual drought. Storms that once brought regular rainfall to coastal areas now veer inland or dissipate entirely. The ocean, diminished in volume and altered in temperature, can no longer perform its ancient role as the planet's great weather stabilizer. Marine biologists have documented changes that go far beyond simple water level measurements. Phytoplankton, the microscopic plants that form the foundation of all ocean life, are failing to thrive in waters that have become too warm, too acidic, or too depleted of nutrients. These tiny organisms require specific conditions to photosynthesize and reproduce. As these tiny organisms disappear, they take with them the complex ecosystems that depend on them. Commercial fishermen report catches that have declined not by percentages, but by orders of magnitude. Species that were once considered inexhaustible now appear on endangered species lists. The ocean's biological productivity is declining even faster than its physical volume. The indigenous peoples of coastal regions, whose oral traditions stretch back thousands of years, speak of changes they've never heard described in their ancestral stories. In Alaska, Inuit elders describe ice patterns they don't recognize. Along the Pacific Northwest coast, Native American fishing communities find that salmon runs no longer follow ancient patterns. Elders who learned to read the ocean's moods from their grandparents find that the old knowledge no longer applies. The subtle signs that once announced the arrival of certain fish species no longer correlate with the abundance they once predicted. Ceremonies that celebrated the ocean's bounty now commemorate its absence. In research centers where sophisticated climate monitoring equipment hums quietly day and night, scientists work with data that tells a story even the most pessimistic models fail to capture. The rate at which the ocean is losing water has not just accelerated, it has accelerated exponentially. Computer simulations that once predicted changes occurring over centuries now compress those same transformations into decades. Ice sheets that were expected to remain stable for hundreds of years show signs of collapse within a human lifetime. Ocean currents that have persisted since the last ice age show weakening that could lead to complete shutdown within the next few decades. These researchers have identified what they quietly refer to as tipping points, moments when gradual changes suddenly cascade into rapid, irreversible transformations. Some fear we may have already passed certain critical thresholds without realizing it. The ocean's circulation patterns could weaken or even stop entirely if current trends continue. Without these great currents to distribute heat around the planet, regions that have enjoyed temperate climates for thousands of years could face temperature swings that would make them uninhabitable. As we peer into possible futures, we encounter scenarios that challenge our most basic assumptions about life on Earth. Coastal cities that have stood for centuries might find themselves not threatened by rising seas, but stranded as the ocean retreats beyond reach. Venice, built on the assumption that the Adriatic Sea would always lap at its foundations, could become a city of canals without water. The great river deltas that have supported civilization for millennia could become salt-crusted wastelands. The monsoons that bring rain to billions of people could weaken or shift, leaving some regions in permanent drought while flooding others with unprecedented deluges. Yet within this sobering picture, we also find stories of adaptation and hope that remind us of humanity's remarkable capacity for innovation. In regions where the ocean has already begun its retreat, communities have started to reinvent their relationships with water. In Palestine and Jordan, engineers have perfected desalination technologies that can produce fresh water from seawater more efficiently than nature's own evaporation cycle. Ancient techniques for capturing and storing rainwater are being rediscovered and improved with modern materials. New forms of agriculture that require minimal water are being developed. Cities are learning to function with careful water recycling and conservation methods. Singapore processes wastewater to standards higher than most natural drinking water sources. The ocean that surrounds us has always been more than just a body of water. It has been our planet's memory, storing within its depths the chemical history of every era. As we watch it change in ways that compress millions of years of natural variation into mere decades, we're witnessing not just an environmental crisis, but a fundamental shift in the story of our world. Perhaps most remarkably, this transformation is happening largely in silence. Unlike earthquakes or volcanic eruptions that announce themselves with dramatic fury, the ocean's retreat occurs so gradually that it can be easy to miss. Each day the changes are so small as to be nearly invisible. Each year they accumulate into patterns that become undeniable. Fishermen notice that familiar landmarks have moved slightly farther from shore. Coastal residents observe that high tide doesn't quite reach the rocks it touched in previous years. Children grow up thinking the current shoreline is normal, having no memory of how it looked before. As night falls over waters that have grown smaller and more distant, we're left to contemplate what it means to live through such a time of transition. The ocean that has been our constant companion throughout human history is teaching us once more about the power of change. In its quiet retreat, it reminds us that nothing on Earth, not even something as vast and seemingly permanent as the sea itself, remains unchanged forever. And in that reminder, we find both the sobering reality of our current moment and perhaps the wisdom to navigate the uncertain waters that lie ahead. For if the ocean can teach us anything in its disappearance, it is that adaptation and change are not just possibilities, but the very essence of life itself. In learning to live with less water, we may discover what it truly means to value what remains.